Hi everybody, my name is Joel Keller. This is my daughter Ruth Keller, and this is my son Nolan. They're going to be my assistants today. The lab that we're going to be working through with you is the reflex and sensory physiology lab, and we're going to start by addressing the learning objectives for this lab, what we hope to learn. We're hoping to be able to explain the association between taste and smell, first and foremost. Then we'll also be wanting to be able to describe the mechanisms of hearing and balance, identify the structures and functions of the eye, and order the nervous system pathway from the initial stimulus to the final response. And we will be right back. All right, as we move on to the actual experimentation step, we find
Daddy,
more specific learning.
Hold on. Like this.
Okay, go ahead. We have more specific learning objectives in that we want to analyze the association between taste and smell, which is actually not more specific. Test hearing loss in specific areas of the ear. Analyze the association of vision and balance. Test your blind spot range and examine an after image. And then I'll be showing pictures of the cow eye dissection we did when we first did the lab. So let's get our stuff together and then we'll start with the experiment. All right, here's a collection of all the items we're going to use today, with the exception of the items that were disposed of after the dissection. I'll go ahead and read the list off of things you would need to do this originally once I finish the video of showing you the actual items we still have to complete the some of the portions of the experiment. All right, so that's all the stuff that we have now, but the full list is as follows: an assistant, mine are playing in the yard right now, a bottle of bleach, camera, which is the computer, coffee grounds, dish soap, glass of water for drinking, lemon juice, we're going to use a lemon, pair of scissors, pen or pencil, resealable plastic bag quart size, roll of paper towels for spill, set of old clothes for dissection, we're not actually doing that today, sheet of white paper, source of tap water, spoon, stopwatch, which I'll use my phone, table salt, wall or chair, and then white granulated sugar. Those are all the items that we had to come up with on our own. Supplied by HOL was a dissection apron, dissection specimen, the cow eye, face mask with ear loops, flexible measuring tape, foam pad, pair of gloves, pair of safety goggles, tuning fork, 9-piece dissection kit, bunch of stuff in it. And then, so basically with all this stuff, we're ready to go ahead and start the experiment. All right, so we're going to start the tasting lab portion of the lab. Nolan, don't touch anything. Let me touch it for you. And my assistant Nolan here is going to perform the salt portion, and then Ruth is. So the directions say to gather all the stuff, wash your hands thoroughly with soap and water, which we have done, and then pour a small amount of salt into a spoon. We have a spoon with salt in it. Now hold your nostrils, hold your nose, so that you can't smell anything. Hold it, bitch. Now lick your finger, your pointer finger. Stick it in the salt. Hold it up like this. Place the salt crystals from your finger onto your tongue and attempt to taste it. Go ahead and place it on your tongue. Do you taste anything?
Yeah.
What do you taste? Oh, you're supposed to. You have to plug your nose, son. That's the point of the whole thing. Can you taste anything with your nose plugged? There you go. So we have a no taste with the nose plugged and salt. So moving on.
Can I put some in the
Go ahead and take a drink of that water. Swish it around in your mouth.
Don't swallow it though.
Yeah, go ahead and swallow it. It says rinse, and generally that means spit it out, but we don't want to go through all that trouble right now.
Swallow it.
Now, go ahead and swallow.
I swallowed it all of it.
Okay, got it. Now lick your finger. Your pointer finger again. Lick your pointer finger again. Dab it in the salt. Go ahead, put it in the salt.
Put up.
Okay. Go ahead and put it on your tongue. Now close your mouth. None, you don't have to plug your nose. You don't plug your nose this time.
Hmm?
Do you taste anything?
I did taste anything when I drink water.
Do you taste anything now with your nose unplugged?
Yeah.
Yeah, you taste salt, right?
Yeah. Let me try.
Oh. All right, Ruth, you want to go ahead and do the experiment as
But
well?
I wanted to put it in there.
Well, we're not on that one yet. We'll get to that eventually. So go ahead, Ruth. Go ahead and do the salt. Hold your nose. You taste anything? What do you taste?
Salt.
You taste salt, but you have your nose plugged. Do you have your nose plugged? You still taste salt? Interesting. Okay, unplug your nose. What do you taste now?
Still salt.
Still salt? Is it a lot stronger with your nose unplugged?
Yeah.
That's because your nose helps you to taste. All right, so the experiment continues. The taste experiment continues in the same way with the coffee grounds, the sugar, and the lemon juice.
Oh, I hate lemon juice.
Oh, and the idea that you realize there's a difference between tasting
I don't want to taste
with
it.
your nose and without your nose. So you can taste a lot better with your nose. Now, Nolan, you want to go ahead and dip your finger in the lemon juice?
It might splat.
Go ahead and taste it. You taste it pretty good, huh? Woo! What's that taste like?
Lemons.
Lemons, right? Why don't you dip your finger in the coffee? Dip your finger in the coffee.
I like coffee.
Well, you have to try to see what it tastes like. Well, if you don't want to taste it, go ahead and plug your nose. Go ahead and plug your nose. Now try it.
I tried it before.
Now
And I liked it.
And you liked it?
But I liked
Well, do you like it now? It doesn't look like you like it at all. All right.
No, but the sugar.
All right, Ruth. Yeah, go ahead and do the sugar now. Just a little. It doesn't need to be a lot. Just a little. Yummy, huh?
Now my turn.
Now it's Ruth's turn.
You know, I hate lemons.
All right, Ruth, go ahead and do the lemons. Oh, it's a little bitter, isn't it? Oh, no, stop spitting. This is a science experiment and for posterity, so you need to refrain from spitting and putting your bodily fluids all over the place.
It's
All
your
right,
turn.
now try the coffee.
Now the sugar.
Now try the sugar. That should help with the coffee taste.
Now that.
Okay, go ahead and wash your mouth out. Alright, so the next part of the lab is kind of beyond the kids. It'd be very difficult to do with kids, I'll put it that way. So what we're doing now is we're testing the sensations and the taste buds on the tongue, on the different parts of the tongue, to see if there's any difference between the front, the tip, the back, and the sides, and like. So the way we're going to do that is with our nose unplugged, we're going to go ahead and start with the salt, and we will eventually get around to each part of the tongue. So we'll take the salt, same thing, lick the finger, and we'll test it first on the tip of the tongue. So right on the tip, not whole much, we get a little bit farther back in, and you can taste it. So on the top front of the tongue, you can taste it more. On the sides, don't really taste it. And the back, can't taste it there either. You can feel it reacting with the saliva in your mouth, but you can't taste it. So, so the salt, from my perspective, you can taste best on the front top, not the tip, the front top of the tongue. And as I went through the sugar, I tasted best on the tip, whereas the lemon juice on the sides of the tongue and the coffee was tasted mostly in the back of the tongue. You can taste it pretty much everywhere to some degree, but there are certain parts of the tongue where it is more pronounced. So I think that will go ahead and conclude the lab once we've done all 4 substances. All right, now that we've conducted some experiments with taste, we're going to move on to the sense of hearing. And for that, we're going to need our tuning fork. The first test that we're going to do is called the Weber test. All right, rejoining me for this portion of the lab, the hearing, is Ruth, and she's going to be performing the Weber test. So Ruth, go ahead and locate an area on your skull that is on the medial area on the top of your head. So right down the middle, on the top. Locate on your head. No, not yet. Not until I tell you. You need to find the spot on your head where you're going to put the fork first. So about there, that's a good place. Pull the hair away from that area of the skull so that you can feel the scalp. You got to be able to feel the skin. Yeah, there you go, just like that. Okay, now strike the tines of the tuning fork. So give it a bing. Now, nope. You need to wait. Strike the tines of the tuning fork on a hard surface as a table, and then place the handle of the tuning fork on that area of the scalp. Pushing with slight pressure. So what you're going to do is you're going to strike it like that, and then put it here,
Daddy,
right on your scalp. There.
Dad,
Go ahead.
Daddy, I
Go ahead and take Oliver outside.
Oliver, outside! He is outside.
So here's the question, Ruth. Can you hear it just the same in both ears when you do that? All right. We're going to actually go ahead and stop. Daddy's going to take over.
Daddy, I was.
All right. So I'm going to go ahead and perform the Weber test, which is I'm going to go ahead and the medial part of your skull. On your skull, you're going to find a bit of scalp, which is pretty easy for me. And then you go ahead and strike the tuning fork. Place it on there. See if you can hear it stronger in one ear or the other. Let's try that again. No, I think I pretty much hear it the same in both ears. So that's the Weber test. Next, we're going to do the Rennie test, which we're going to strike the tines And then we're going to place the handle on the mastoid process behind my right ear. So I'll go ahead and do that, which is right there. Wow. So what you do is once you stop hearing it, which was just a second ago, then you hold it up to your ear and all of a sudden the sound comes back. So that's the Rennie test. And basically I came up as being normal because I heard it the way that you're supposed to. Alright. So next we're going to move on to the balance test. Alright, so Nolan is my assistant for the balance test. And this experiment's going to be performed by standing on one foot with eyes open and standing on one foot with eyes closed. So the goal is for him to stand for a minute. Nolan, are you ready?
Yeah.
Look at the camera. Look right here. Pick up one foot. You can put a hand on the chair so you don't fall over. Don't lean on the chair. All right, go ahead and stand on one foot. I'll come and help you. But you have to stand a little longer.
Well, I can stand longer than that.
So we're going to stand on one foot.
I can stand on one foot easy.
I've actually got enough balance that Nolan can pull himself up while balancing. All right, you get the idea. I can balance on one foot. Now, what we're going to do, Nolan, are you ready to go ahead and put both your feet down? You ready to close your eyes and balance on one foot?
Yeah.
All right, on count of three, close your eyes and then balance on one foot. 1, 2, 3. And we're finding, once we close our eyes, that it's much more difficult to balance on one foot. It's very difficult. We lost Nolan. And we lost Daddy. So that shows you how much your vision has to do with your balance. All right, so we're moving on to the vision portion of the test, and Ruth is going to be my assistant for this one.
Oh,
And what we've done is we followed the directions on the lab. We cut out a 10 by 10 centimeter square of paper, put a black X, a cross, black cross, or a plus sign, whatever you want to say, 2 inches off the side in the middle, and then the same on the opposite side, we put a black dot 2 inches off the side in the middle. So what we're doing here is we're going to cover our left eye, hold it out at arm's length, looking at the plus with your right eye, and then you bring it back to your eye, staring at the plus until you cannot see the circle, the dot in your peripheral any longer. And that is the test. So Ruth, go ahead and show us. So once, so when she can't see the dot anymore, she's going to tell me.
It's gone.
Okay, stay right there. Don't move. So we're going to measure the distance from her eye, more or less. So we're going to get 21 centimeters. 21 centimeters. All right, now you're going to do the same thing with the other eye now. So cover the right eye. You're going to flip this paper over so that the dot's on the outside still. And you're going to repeat the experiment using your left eye. Go ahead.
It's gone.
So what we got here is we got 22 centimeters. So we're about the same on each one.
21 and 22.
All right, so finishing up our vision portion of the lab is the after image. What we're going to do is we're going to stare at the plus sign for 30 seconds. Stare without blinking, 30 seconds, and then we're going to quickly move our focus away to a blank white portion. I'll go ahead and use this blank white piece of paper, and then we'll see what happens. So, here we go.
You blinked.
I know I blinked. It is what it is. I think it'll still work if I blink.
Is it gone?
No, it hasn't been 30 seconds yet either. Can you let me know when it says the minutes or the seconds says 02 on the computer?
Zero two.
So when I moved to a white portion of the paper,
Daddy,
I saw an after image
21.
of the plus.
Wait, can I try?
So that's the after image that we're
Can I
gonna
try?
do. Yeah, you guys can go ahead and try. All right, so this vision lab, what's really going on here is that the other eye compensates for the blind spot. So when you cover one eye, you end up with a blind spot because there's no other eye to compensate and see it. The after image is a result of photoreceptors getting lazy in your eyes, and rather than getting samples, it just goes with the last image it had for a certain amount of time. And that's really the basis behind the findings. All right, so now Nolan is my assistant, and we're gonna test his reflexes, just like your doctor did way back in the day. So what we're gonna do is we have him sitting so that his legs are dangling. At least his legs are dangling. And then Nolan, relax. We need to do this experiment, so you need to sit still. All right, so we're gonna take and we're gonna strike his knee just below the knee.
You mean cut it open?
And we're gonna see what happens. No, we're gonna strike it, not slice it. Ready? Just relax. Just let go. Don't flex your muscles at all. Oh, missed. Try again.
Ow.
Sorry.
Ow.
Oh, got a little jump there.
Ow. 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 Ow.
Okay. Alright, we don't have another cow eye to dissect, so we're just going to take a minute to look at the pictures of the dissection, where we started off by just kind of cleaning up the fat and the other stuff clinging to the eye, and then identifying the optic nerve, the cornea, slicing open the cornea, looking at the lens, and vitreous fluid, and all that good stuff. So take a second and look at these pictures, and it should give you an idea of how the lab went down. I see the creator more in the eye than in any other organ because it's so intricate, it's so delicate, and I just can't wrap my head around how that could be part of an evolution per se, because it just feels like image of God sort of thing, like it was described in Genesis 1:27, where it says that man was created in God's image. It's the sort of organ that really drives the point home for me, because I really can't reason my way into believing that the eye was a product of evolution. And even Darwin himself
accepted that the eye contradicted his own findings, not necessarily dispelled them, but it gave him pause, as I believe it should anybody, just seeing the complexity and the intricacy in the eye. It just, to me, is undeniably a gift endowed by a creator.